We're going to talk about properties now. So,
Take it away.
where should we start? Yeah.
All right. So if you recall, properties are in classes. So we have to have a class here. And the class animal will have a property, say name, which is of type string. So this is a property, and it's going to complain because it doesn't know initializers. We'll initialize it to an empty string for now. And I want to talk a bit about this is sort of the simplest syntax of properties. And well, I guess string, let's create another class called leg. And legs have a length. So animals will also have legs. Well, we'll call, okay, we're going to make this a bit weird. It's going to be legs, and legs will actually store the number of legs.
Right. And some animals, of course, don't have legs.
Well, they just have 0 legs.
Fair.
All right. So the reasoning behind this is because it's interesting to see. So now you have a class that contains another class, right? And whenever you, and here what I want to talk about is the concept of ownership and memory management. So whenever you have a class, it's allocated and initialized, and when you're done with it, it gets deallocated. And this is done in Swift. In many languages have many different ways of doing this. Famously in C, you have to do it manually, and you have to allocate and deallocate memory yourself. In Swift and Objective-C, there is this concept of ARC called automatic reference counting. And what that means is whenever you define an animal, right now dog holds a reference to the type animal, a new animal, and you don't want, and when you assign dog to, like, you want, when dog goes out of scope or goes away, we can't really demonstrate that here, you want animal will automatically be deallocated. You don't want it to be taking up memory. And this is done by reference counting. When you assign it, this animal object you recreated, which sort of floats in space, you have a pointer to it from dog, you have a reference to it called dog, and this increases its reference count by 1. So it's being referenced by 1 variable right now, and so it needs to be a lot. And when dog goes out of scope, basically dog is gone, then it gets decremented, and now it has 0 references and it gets deallocated. And that's the basic concept behind all of memory management in Swift. And so here when we do dog equals animal, this variable owns the class object you create, and that means that, that's sort of literally it owns it. So when it's gone, then nobody owns it anymore, and so it's gone as well. And what I want to get to after all this is that an animal owns its legs in this case, which means when you create an animal, it will create some legs. But when the animal is deallocated, the legs will lose its reference and also be deallocated. And that's all very logical, but imagine this another case where we have a vet. And the vet is, this is very sci-fi. It can take an animal's legs. It treats legs like a leg vet. And when it treats legs, it needs a reference to someone's legs. So it also has legs, and it also points to legs. And maybe it's optional because it might not be seeing any animals. But the difference now is that the leg vet, its legs, it's operating on them. It doesn't own these legs. In this case right now, if we instantiate a vet, and we gave it the dog's legs, and then we somehow deallocated dog, vet would sort of, whenever you assign it, as I said, the reference would be incremented, and vet would own the legs, which isn't correct. And so there's this concept of strong and weak properties, and this is the main thing I want to talk about. And here, it's effectively a strong variable that's going to complain because supposed to be like, that's strong. Or maybe it's not supposed to be strong at all. I guess it can only be, we want to talk about optionals here. Because it defaults to strong, you don't have to specify it anymore. That's the reason it was complaining. But so with the weak attribute, this is now a weak reference. So when you assign it, it doesn't increment the reference count of that object, and so it doesn't own it. And that this is a very important concept, and to prevent memory leaks in your program. And sort of the way I framed this and the way you should think about it is with ownership. And if something owns it, it should have a strong reference to it. So if I'm alive, you should be alive because I own you. But if you have a weak reference, you don't own it. I just have a reference to you. I merely have a reference to you, but my sort of lifetime is not connected to yours. And if I was deallocated, it doesn't affect you. And if you were deallocated, my reference will just be nilled out. So like, if now that it's weak, if dog was deallocated, vet.legs would actually be assigned back to nil for you because it's a weak property. Does that make sense?
It makes sense.
Yeah. So that's basically all that was just to understand the weak pointer, which you also see throughout the course. And beyond that, there's also other attributes you can add, and some are pertaining to, and we're just going to sort of demonstrate them here.
Okay.
Classes, since in Swift everything's in one file, you can't do access control as easily as languages that have two files. Like if you have a header file, you can put everything public. And by access control, I mean like public and private. You can put everything public in the header and everyone else can see it. And then anything that's not in the header is sort of private to you, right? But in Swift, everything's in one file, but often you don't want everything to be public. And so there's the private attribute, which makes legvet private, which means only this file. And since we're in the playground here, it doesn't make too much sense. But only this file and the things within this file can see that legvet has legs. And if you went to a different module, a class would not know, a different file would not know because it's private. And the same, there's public, which will give a warning because the class also can have these attributes. And it needs, if the class is not public, then there's no point to have a public property in a non-public class. Yeah.
But what is a default class versus a public class? What is the difference there?
Right. So the third type is called protected. And protected is sort of like public. And you don't have to type it again because it's default. The default is protected, which means your module can see it. And that's sort of a project level concept, which means everything within the same module, like all of your code, your app, should all be able to see it. But it's not public, so if you integrated like a library, you wouldn't be able to see its protected classes, but it would be able to see it within itself, its own sort of module. Yeah, so that's sort of public, protected, and private, and it can be used for access control on properties and classes and methods as well. And the next cool thing, which is now like in Swift, is called new to Swift. Let's delete the vet. It's kind of weird. It's called property observers. So and we'll talk about this alongside with computed properties. So you can have sort of a property that depends on another property, like a, say, uppercase name, which is an interesting example. And it sort of, you can, it is defined by its name. You don't want to set it, you only want to get it. So we're going to define a getter for it. That basically just returns names, uppercase. And what this does is uppercase name is a property, but it doesn't store anything, right? It's sort of, it's a computed property. Whenever you access it, it computes its value from some other values in your class. And in this case, it takes the uppercase value of your name. And you can give it a setter as well, which doesn't really make sense. So the syntax here is you can for your variable, you can give it a scope, and you can type get to define the getter, and you can type set to set the setter. and setter gives you the new value, so we're just going to set name equals to in the setter you automatically get this new value variable, and this doesn't. So if you set the uppercase name, it'll just set it directly to the name, and this makes it a computed property. It behaves exactly like a property from the outside. You can access it and set it, like you can set uppercase name equals something or get uppercase name, but internally it's not storing anything. It's really just modifying name and using it as sort of it's computed from name every time. Yep, so that's a computed property, and yeah.
There's a few more topics that we should
There's
talk about. But
There are a few more topics, but these videos have been getting a bit long. So I think we're going to leave it at that and provide some references you can look at for more stuff into properties.
yeah, so look, there's a lot of these types of advanced concepts that we can go into. I think in the remainder of this module, we'll touch upon some items that might be important or some things that might be relevant. But the idea here is that we won't go into depths into every single topic, especially if there are things that you may if you see something that you don't know how the code works, you can find it. You can search for it. So our goal is not to cover every single thing in Swift, but give you enough that you could write your own basic app. That's really the goal and motivation that we have.
Yes, and definitely we want to try to cover the important topics that will be relevant throughout the course. But anything outside of that, we'll leave it up to you to learn it, and we'll provide you with some references.
Yeah. And you might see certain ways, for example, the weak property definition or public and private. If you see those and you see something that we haven't talked about in these lectures, you can always find out more about it. So, yeah, I guess that's it for properties for now.
That's it for properties.